Jai Hind, dear students. I am Dr. Preeti, and today we are with the last part of our chapter Acids, Bases, and Salts. In the previous video, the last topic that we have seen was about chloralkali process. In that process, we have seen the manufacturing of chlorine gas. Now, today we are going to see about some of the other salts of sodium and also one of the salts that is going to be manufactured by using that chlorine gas. Okay, so we are going to see about some of the salts. So just let's start with that. These salts are very important for your exams. So the first salt that we are going to consider is bleaching powder. Okay, so first we are going to see about bleaching powder. The formula of bleaching powder is CaOCl2. It's also known as calcium oxychloride, CaOCl2, and its scientific name is calcium oxychloride. Now, how we will prepare this calcium oxide? We will take dry slaked lime. Dry slaked lime is CaOH whole twice, and we'll pass chlorine gas through it. And when we'll pass chlorine gas through it, then we will get calcium oxychloride, that is bleaching powder, and water. This bleaching powder is a very good oxidizing agent. So it is used in various industries and in laboratories also as an oxidizing agent. Okay, you all know that oxidizing agent is one that causes the oxidation of other substances. So it's a very good oxidizing agent. For that purpose, we are going to use it in laboratory and in industries. Apart from that, bleaching powder, its name only suggests that is going to be used for bleaching, and bleaching means decolorizing something. So when we have to decolorize something, if you have stains on your clothes and you want to remove those stains, then also bleaching powder will be helpful. So what are the uses of bleaching powder? That is used in the bleaching industries, in textile, as a bleaching effect in textile industries, in paper industries, as well as in laundry. After washing the clothes, bleaching is done to remove any leftover stains. Now you may be wondering why it is used in paper industry, because paper industry uses wood as a raw material, and wood, you all know, it's not colorless, but you want your paper to be white, you want it to be colorless. So to decolorize that paper pulp, that is first treated with bleaching powder. Okay, and apart from that, bleaching powder is also used as a disinfectant to kill the germs present in water. You must have heard about chlorinated water. So this chlorinated water is prepared by using bleaching powder. It is mixed in water that will kill the germs of water. Okay, it's a disinfectant. So for every compound that you read, you should know its preparation, its common name, its formula, and the uses. At least two uses for every compound should be memorized by you all. Okay, now the second compound that we are going to talk about is baking soda. Baking soda is prepared by using NaCl, and it is mixed with sodium chloride is taken, and it's mixed with water, it's dissolved in water, and ammonia gas is passed through it. Ammonia is added to it, NH3. Okay, during the process we get NH4Cl plus baking soda, NaHCO3. Apart from that, sorry, I forgot, carbon dioxide gas is also passed through it. So we take aqueous NaCl, means NaCl dissolved in water. We pass carbon dioxide gas through it and add ammonia to it. We'll get ammonium chloride, NH4Cl, and we'll get NaHCO3. Okay, so the formula of baking soda is NaHCO3, and its name will be sodium hydrogen carbonate. Sodium hydrogen carbonate is sometimes also known as sodium bicarbonate. So that will be formed. Now, if you are asked to write the formula of baking soda, don't write the whole reaction. I find that sometimes the students forget that this is baking soda, this one is baking soda. So just they write the whole equation. So if you are asked the formula, just write the formula that it's NaHCO3, that is baking soda. Okay. Now, as the name only suggests, it is going to be used as for baking purposes. Okay. Apart from that, if when you heat baking soda, what is going to happen? Let's see that. So if you have baking soda and if you heat that, you will get Na2CO3, means definitely you are taking 2 molecules of baking soda. You'll get Na2CO3 plus water plus carbon dioxide gas will be escaped out. Carbon dioxide gas is formed by the reaction of baking soda and with some acids also, and when we heat baking soda, then also carbon dioxide gas is formed. This carbon dioxide gas form is very useful in certain uses of baking soda. We'll see that. Okay. So how will we are going to prepare baking soda? What's the formula? NaHCO3, sodium hydrogen carbonate. How we are going to prepare that? NaCl mixed with carbon dioxide. Carbon dioxide gas will be there. NaCl we have taken dissolved in water only, and we'll pass NH3 to it. Then we'll form ammonium chloride, NH4Cl, and baking soda, NaHCO3. Okay. Now from NaHCO3 we can prepare Na2CO3 also, sodium carbonate. And now what is this sodium carbonate? The next compound that we are going to read about is washing soda. So this washing soda is Na2CO3 only. Okay. So by using baking soda we can prepare washing soda as well. Na2CO3 plus carbon dioxide gas will be escaped out. Now we come to the uses of baking soda. Baking soda is used for making crispy pakoras at home. Hai na? So when your mother is frying pakoras and you have and she wants to make it very crispy, then also for that purpose baking soda is added. It also helps in the quick uh, like cooking of food. For example, if your mother is preparing chole or rajma, that is kidney beans, then ask her. Sometimes she adds baking soda with that to make it the cooking to be faster. Okay, so it also going to help in faster cooking. Apart from that, it is, as the name suggests, it is used for baking purposes. For example, if you want to bake a cake, then also you can use baking soda. Okay, so why it is helping in the baking process? Why it is helping to rise your cake, to make it fluffy, to make that holes in that cake? So how is it doing that? Let's see that. Actually, baking soda is sometimes also used as baking powder. What is baking powder and how is it different from baking soda? Let's see that. In baking powder, we have baking soda, and apart from that, we add some mild edible acid. So a mild edible acid could be like tartaric acid. It's a mild acid and it's edible. Okay. So when we add some mild edible acid with baking soda, that will form baking powder. And now what will be the reaction? We have baking soda, we have hydrogen ions. It could be from water, so we can just get it from water also, hydrogen ions. When we mix it in baking soda in water, then also the reaction will be there. And when we are adding tartaric acid or any mild acid, then also this hydrogen ions will be there in that acid. And so what will be formed? We will be having water, carbon dioxide, and sodium salt of an acid. Okay, whatever acid we have taken, depending on that, sodium salt of acid will be formed. Okay, but this carbon dioxide gas that is formed during the process, it's very important. It's a gas, and so it will try to escape out. While escaping out, it will leave some holes in your food item, and that will leave that sponginess in your cake, or if you're preparing dhokla, so that gaps or that netty areas that will be created because of this escaping out carbon dioxide gas. Okay, so that is why this baking soda is used for baking process. Next use of baking soda is in soda acid fire extinguishers. Okay, so in fire extinguishers also we want a gas that can extinguish fire, and baking soda is producing that, carbon dioxide. Okay, so soda acid fire extinguishers have baking soda, and there is a separate container containing acid also. So when we turn on that extinguisher, then the acid and the baking soda mix with each other. That produces a lot of carbon dioxide gas, and this carbon dioxide gas will be helpful in extinguishing fire. Okay, so that is why baking soda is also used as a fire extinguisher. Okay, so once we revise everything, baking soda formula is NaHCO3, sodium hydrogen carbonate. Its uses, first its preparation. It's prepared by using aqueous NaCl, by passing carbon dioxide gas and ammonia to it. Then we'll get ammonium chloride, NH4Cl, and NaHCO3, that is baking soda. Okay, now the uses of baking soda. Baking soda could be used to prepare crispy pakoras, or faster cooking also we use baking soda. Then we can prepare washing soda from baking soda. Apart from that, baking powder contains baking soda and a mild edible acid like tartaric acid. Next we have that baking action, how it is going to have that baking action. So sodium hydrogen carbonate or baking soda, when reacts with H plus ions, this H plus ions could be from water or could be from a mild acid like tartaric acid that we are adding to it. Then what will be formed? Carbon dioxide gas will be formed. This carbon dioxide gas will escape out of our food item, and that will create the spaces between that. Okay, so that was all about basic baking soda. And last use of baking soda we have seen was it is used in fire extinguishers. Okay, so now we will see about our next compound, that is washing soda. As the name suggests, only it is going to be used for washing of clothes. Okay, for laundry purpose we are going to use washing soda. Washing soda, the formula is Na2CO3, that is sodium carbonate. Okay, and we have already seen its preparation by heating sodium hydrogen carbonate. When we heat it, we get sodium carbonate. Sorry, CO2. We get sodium carbonate. Now when we leave this sodium carbonate in environment, it will recrystallize. It will combine with the water molecules present in atmosphere. With 10 molecules of water it is going to combine, and it will form Na2CO3 dot 10H2O, and this is the formula of our washing soda, Na2CO3 dot 10H2O. So is our washing soda going to be liquid? Because it's having 10 water molecules. So is it going to be wet? No. Our washing soda will be completely dry only. This water molecules, when present in a crystals of any of the salts, they don't make it wet, and such water molecules are known as water of crystallization. Okay, so these water of crystallization are the water molecules that are present in a salt, but they don't make it wet. They just are present in the crystals of that particular salt. Okay, one common example of water of crystallization I would like to share with you all, that's not given in NCERT book, that is alum, that is fitkari. You must have seen a fitkari or alum at your home. So that is completely solid, but each molecule of alum is having 24 water molecules with it. Okay, so it's an example, it's an excellent example that is there at your home, by which you can remember water of crystallization, never make a substance liquid. Next, we are going to see about further uses of washing soda. Okay, so washing soda is used for laundry purpose. It is used in glass industry, and textile industries, as well as in paper industries. The purpose is the same, to clean the paper pulp, wood pulp, for that purpose, we are going to use washing soda. Apart from that, washing soda is also used to remove permanent hardness of water. Important as a 1 marks question. So, washing soda is used as to remove the permanent hardness of water also. Okay, that is another use of washing soda. Apart from that, washing soda is we use it for daily for cleaning purposes, cleaning of various things. We can use the washing soda. So these are the uses of washing soda. Okay, next compound is plaster of Paris. But before talking about plaster of Paris, we'll pause a little bit with the salts and we'll talk about water of crystallization. As we have seen in this topic, water of crystallization, sodium carbonate was having 10 water molecules as water of crystallization. So first we'll talk about water of crystallization somewhat in detail, and then we'll move on to plaster of Paris. Now, certain molecules are there that have water of crystallization. For example, copper sulfate, CuSO4. You must be aware that copper sulfate crystals are blue in color, but they are blue in color because of the presence of water of crystallization. CuSO4.5H2O. 5 water molecules are present in one molecule of copper sulfate, and that only gives a blue color to its crystal. If you heat copper sulfate, if you take copper sulfate in a test tube and you heat it, you will find that water molecules are escaping out, and you can see that droplets. If you close that lid, you can see that droplets collecting on the lid by the process of condensation. Okay, so this is water of crystallization, and once water of crystallization is removed from copper sulfate, it is no longer blue in color, then it is white in color. Okay, it's colorless crystals actually. So copper sulfate 5H2O, water, this 5 water molecules are the water of crystallization. Similarly, we have seen that Na2CO3.10H2O is there. Apart from that, gypsum is another molecule, CaSO4.2H2O. Okay, so gypsum is the another molecule that is having 2 water molecules as water of crystallization. Next molecule, next salt that we are going to study about is plaster of Paris, that is also having water of crystallization. So let's have a look about plaster of Paris. The formula of plaster of Paris is CaSO4.12H2O, calcium sulfate hemihydrate. Hemi means adha, okay, half. So it's half water molecule attached with 1 molecule of calcium sulfate. That is why we call it as calcium sulfate hemihydrate. Now, this calcium sulfate hemihydrate is prepared using gypsum. So what do? We take gypsum, I hope you remember, CaSO4.2H2O, and we start heating it. Okay, and we heat it at 373 Kelvin. Okay, then what will be there? 1.5 water molecule will be removed from it, and we will get CaSO4.12H2O. CaSO4.12H2O will be formed, and the CaSO4.12H2O is plaster of Paris. Okay, now you might be wondering that how will I remember this 373 Kelvin? How will I remember that this much temperature is there? So it's not a difficult thing. It's something that you already know. What is 373 Kelvin in degrees Celsius? If you convert that, that means 100 degrees Celsius, and that is the boiling point of water. So the water will start getting converted into its vapor state. Okay, so it's nothing difficult to remember. It's just at the 100 degrees Celsius that you are heating it, and you are removing the water from it by evaporation. So you are left with CaSO4.12H2O. Okay, I'll tell you what is the meaning of half H2O. How we can have half a molecule. The molecules couldn't be divided into half portions, na? So I'll let you know about that also. But before that, the uses of plaster of Paris. This plaster of Paris is used for repairing of fractured bones. So if you have a bone that is fractured, now that has to be kept in place. So this plaster of Paris is always stored in airtight containers. Always remember that. Plaster of Paris is always stored in airtight containers, and when you want, it is there in the powder form. It is available in the powder form. So when you want to repair a bone, that is made wet immediately, and then it is given a particular shape. It is moldable. You can easily mold that, and you can give it a particular shape, and it is wrapped around the fractured bone, and once it becomes dry, it gets converted to gypsum. So when it gets converted to gypsum, it will remain in that shape only. Now it is not movable. So that will keep your fractured bone in position. Okay. Now, one question that comes in your exam from this is, why plaster of Paris needs to be stored in airtight containers? Because if it is not stored in airtight containers, this plaster of Paris is going to react with water molecules present in the atmosphere and convert it into calcium sulfate, like a CaSO4.2H2, that is gypsum. If gypsum will be formed, then this will be as hard as a rock, and you will not be able to use it for any purpose. Okay. Second thing is that plaster of Paris is also used for making statues and giving beautiful designs to your ceiling. You must have heard na POP ki ceiling karwai hai. So this POP designs could be made over the ceilings by using plaster of Paris. Fine. So that are the uses of plaster of Paris. Now, one important thing not mentioned in the book is why the CaSO4 is written as half H2O. Actually, there are two molecules of CaSO4 attached to one molecule of water. Water cannot exist as half a molecule. So actually, two CaSO4 molecules are attached to a single water molecule, and that is only forming CaSO4 dot. That is why we write it as CaSO4 dot half H2O, because every CaSO4 is just getting half of it. The another half will be shared by this one. Okay, so for writing the formula, we write it like that, but actually it exists in the form of CaSO4, two molecules attached to one portion of water, one molecule of water. Okay, that was about plaster of Paris. That is all about the contents given in the book. Now there are certain questions given at the back which are very important. I would like to tell you something from this chapter that is really important. From this chapter, most probably you will be having concept based questions. Concept based questions are like, why we can't put curd in vessels made up of copper or brass, or you could be having a question. I'll let you know about some of the examples. You could be having a question that why a milkman adds some amount of baking soda to milk, and will this milk take a longer time to set as curd? Why or why not? Okay, so let's see, have a look about these questions. A milkman adds a small amount of baking soda to milk so as to reduce its pH, because if milk is there, then it is having some lactic acid, and this lactic acid will be increased in the milk, that will lead to sour taste of the milk, and that will be spoiled. So for making its increasing its before boiling, it could be increasing the duration so that it doesn't get spoiled. The milkman adds a small amount of baking soda, which lowers the pH and neutralizes the lactic acid, and so now the milk will not get spoiled for a longer period of time. Second question is, will this milk take a longer time to set as curd? Yes, definitely. Since its pH is less, it's slightly basic. So for setting as curd, it should be acidic. So it will take a longer time to reach to that pH, and so this milk will be taking a longer time to set into curd. Now, another question that could be there in your exam is there any hydrogen ion concentration in bases also? For example, NaOH, KOH. We were talking about potence of hydrogen, pH. So we were just talking about concentration of hydrogen. Concentration of hydrogen is more in case of acids. But still, bases also have hydrogen ions. But in them, the presence of hydroxide ions is more and hydrogen ions is very, very less. But still, bases also have hydrogen ions in them. Okay, so calculation of pH is just based on hydrogen ion concentration and not on hydroxide ion concentration. So acids will be stronger if they are having more hydrogen concentration, and bases will be stronger if they are having lesser hydrogen ion concentration. Okay, more the hydrogen ion concentration, more acidic is any acid, and lesser the hydrogen ion concentration, more basic a solution is going to be. Okay, so these are some concept based questions, because from for 3 mark question probably you will be asked some concept based question. Okay, for example, we discussed one more question, that what will happen when carbon dioxide gas is passed through lime water? It will turn milky. And what will happen if we continue to pass carbon dioxide gas through this solution? It will turn colorless. Okay, so all these questions we have discussed from the chapter. So just prepare your chapter very well. Don't forget to go through all the NCERT book questions. I'm always there to help you out. If you have any doubts from any of the chapters in science, then please let me know in the comment section. Okay, that's all for today. Good day, everyone.